Hello, Algebra 1. Happy Wednesday. This video is going to be a lesson on 8.6 day 3. We're still going to be dealing with product sum factoring, but we're going to start solving equations using product sum factoring. The last couple of days it's just been learning how to factor. Now we're going to solve using factoring. So what I'd like you to do is pause the video and try the warm-up questions, number 1 and number 2, and see how you do on them. Okay, here is the answers for the warm-up problems. So number 1, you should have gotten x minus 5 times x minus 2. Number 2, there's a GCF first of 2. So we want to divide that 2 out first. Then we get x squared plus 2x minus 15. Then with what's inside the parentheses, we can do product sum, and we get x plus 5 times x minus 3. Just make sure your GCF of 2 is still in the very front of your answer. Okay, so hopefully you got the warm-up right. If not, reach out to either one of your teachers, and we'd be happy to walk through it with you. Okay, so for today's lesson, I wrote steps in the corner of my paper. So what I'd like you to do is pause the video and write down those steps so that you have the exact same steps that I do, and you'll be able to follow along. Okay, so we're going to use these steps in the corner to help us solve these problems for today's notes. Okay, I'm going to try to keep the steps in the video frame as long as I can, and then I'll have to kind of slide it up and down to be able to go back and forth between the problem and the steps. So we'll start with example 3, option A, or problem A. So first it says get equal to 0. So I need to start by subtracting the 15 over to the left-hand side, so that cancels, and I'm left with 0 on the right-hand side. So I have x squared plus 2x minus 15 equal to 0. Now I always check, is there a GCF that I can remove? In this case there's not, because there's a 1 in front of the x squared, so there's no number I can divide out. And then also there's no x that I can remove because the negative 15 does not have an x. So I would say no GCF, but we always want to check. So next, because we have a trinomial, we're going to go ahead and move forward into product sum factoring. If you need to make the product sum chart off to the side, please do so. To make this video as short as possible, I'm not going to be doing the chart. The factors that work here is a positive 5 and a negative 3. Positive 5 times negative 3 gets me a negative 15. Positive 5 plus a negative 3 or minus 3 gets me the positive 2. So we checked for GCF factoring. We then did product sum factoring. Now we can do the zero product property, where we separate them and set them both individually equal to 0. And from here, it should be really easy to then solve each equation. So here we would subtract 5, and we'd end up with a positive 5 as the answer. Here we would add 3 to both sides, and we would end up with x equals positive 3. Okay. Now that problem I explained in a lot of detail. For the next couple of problems, I'm not going to explain as much detail, just again to try to keep the video as short as possible. So for this one, I want to get it equal to 0 first. So this x has to be moved over. Now be careful on the left-hand side of the order that you write the trinomial. The x squared has to come first, then the minus x, and then the minus 20, because we want it in standard form. I check for a GCF, but again, just like the last problem, there is no GCF. So next I do product sum. My two factors that are going to work here is negative 5 and a positive 4. Then I split up and I say x minus 5 equals 0 and x plus 4 equals 0. I add 5 to both sides, so I get x equals positive 5, and then I subtract 4 and I get x equals negative 4. All right, option C, again, I need it equal to 0, so I'm going to subtract the 24, but an interesting thing happens here. I end up with 0 on the right, but because I have a regular 27 on the left, I can go ahead and subtract those numbers and combine like terms. So I have x squared plus 4x plus 3 equal to 0. Now I check for a GCF, but I notice that there is no GCF, so then I go right into product sum. The two numbers that are going to work here for me is positive 3 and positive 1. And now I'm ready to split up and set them individually equal to 0. So here I have x plus 3 equal to 0, and when I solve that, I subtract 3 and get x equals negative 3. The next one, x plus 1 equal to 0, I subtract the 1 and I get x equals negative 1. Now you'll notice that all three of these problems did not have a GCF, so let's try a couple of problems with a GCF. We're going to be following the same steps though. So step 1, get it equal to 0 first by subtracting the 24 over. So I have 4x squared plus 4x, then minus the 24 equals 0. Now in this case, I do have a GCF of 4. So I'm going to remove that 4 first. Divide everything by 4. Now let me explain my division there. 4 divided by 4 is 1, so I didn't write anything in front of the x squared. If you wanted to write a 1, you can. And then same here, 4 divided by 4 gets you a 1, but you don't have to write it. Negative 24 divided by 4 gets you a negative 6, okay? Now we have to do product sum with what's left over inside the parentheses, just like we did in yesterday's notes. So we have to figure out what two numbers multiply to negative 6, but at the same time add to a positive 1. In this case, the numbers that work is positive 3 and negative 2. Now, when we split off and we set them both equal to 0, you technically have to do it with the GCF as well. Now, in some cases, in a lot of cases, you're just going to throw that GCF away because setting 4 equal to 0 does not make sense. So it just kind of goes in the trash. But be careful, in the future we might have a GCF that does not get thrown in the trash, and I'll be sure to point that out and show you guys. So then we take the x plus 3 and set that equal to 0. We would subtract 3 and get x equals negative 3. The other one, we take x minus 2 equal to 0. We would add 2 to both sides, and we would get x equals positive 2. Okay, let's try the next one. Very, very similar. I'm going to subtract the 20 over. Make sure you write it in standard form. And now we have it equal to 0. I do have a GCF. This time my GCF is 2. So if I remove the 2, I have x squared minus 3x minus 10 equal to 0. Then I do product sum factoring. The two numbers that are going to multiply to negative 10 here and also add to negative 3 is a negative 5 and a positive 2. And now we're ready to branch off and set them all individually equal to 0. Again, the 2 gets thrown in the trash because 2 equal to 0 does not make any sense. X minus 5 equal to 0. Add 5 to both sides, and that means we get x equals 5. X plus 2 equal to 0. Subtract 2 from both sides, and we get x equals negative 2. All right. For this one, feel free to pause the video and try it on your own and see how it goes. The first thing we're going to do is add 22x to both sides. Now be very careful to make sure your polynomial is written in standard form to get it equal to 0. The 22x has to go in the middle of the polynomial. Now I do have a GCF of 2, so I'm going to remove that 2, and I'm left with x squared plus 11x plus 30 equal to 0. Now I have to do product sum. I need two numbers that multiply to 30 but also add to 11, and that's going to be a positive 5 and a positive 6. Now I branch off and I set them all equal to 0. Again, the 2 goes in the trash. x plus 5 equal to 0, I subtract 5 and I get x equals negative 5. X plus 6 equal to 0, I subtract the 6 and I get x equals negative 6. All right, so the last two problems are word problems, and let's go ahead and read example 5 together. The Property Brothers want to build a new art studio that has 3 times the area of their old studio by increasing the length and width by the same amount. What should be the dimensions of the new studio? So this diagram is very helpful in giving us a visual. We have the existing studio here. It's 12 feet by 10 feet, and they want to push this wall out a little more. They just don't know how far, so that's why there's an X there. They want to push this wall this way, and they just, again, don't know how far, but notice that they want to push the walls the same amount. That's because the variable is the same. So the bigger square or rectangle is going to be their new studio, okay? So in order to deal with area, we have to talk about, well, what's the area of their original studio? So let's find the area of the old studio. It's a 12 by 10 room. If you multiply those together, we have 120, and that would be feet squared. Okay. Now they want to make it 3 times bigger, right? So the new studio, we don't know the dimensions, but we know that if we take 120 and multiply by 3, the new studio has to have an area of 360 feet squared, okay? So let's think about this. We've got length times width equals area, right? We know the new area has to be 360. So I'm going to erase my A and replace my area with 360. The question is, what is the length and the width of the new room going to be? Okay, well, here's what's interesting about it. We know what the old dimensions are. So let's call the top here the length, okay? It used to be 12, but if we push this wall out and we add more square footage, it used to be 12, but we're going to add X feet to it. So the new length could be 12 plus X if we add that together. So my new length can be written as X plus 12. Same idea for my width. My original width was 10, but we're going to push this wall out and we're going to add X amount of feet. So the new studio would have a width of 10 plus X. Oops, yeah, I guess I'll write it as X plus 10. Now, we're used to having it equal to 0, and we don't have it equal to 0. The weird thing is, if I were to subtract the 360 over, with this not being multiplied out, I wouldn't be able to really subtract it accurately. So we have to multiply the left side out first. I'm going to go ahead and do all of the work in my head and just tell you guys what it would be if we added everything, multiplied and added everything together. So if you either double distribute or use the box method, by multiplying these together, this is your result. Now we can go ahead and follow the same steps that we did up here to be able to solve for the new dimensions. So our first step is to get it equal to 0. So we have x squared plus 22x, and this is going to be minus 240. Now we're equal to 0. I check for a GCF, but I do not have one. So now I can go right into product sum. And I'm going to go over here because I'm running out of space. I need two numbers that will multiply to negative 240, but also add to 22. After a little bit of guessing and checking, even for me, it took a lot of time. I get positive 30 and negative 8. And now I'm ready to branch off and set them both equal to 0. So I have x plus 30 equal to 0, x minus 8 equal to 0. Now here I would subtract 30 and get negative 30. Here I would add 8 and get positive 8. Now one of these doesn't belong. And if you think about what x represents, x is how many feet we are adding. Can you add negative 30 feet to a room? Absolutely not. So you guys, oftentimes in word problems, the negative answer will be thrown away. Not always, but usually, okay? And so this means that we are adding 8 feet to the old dimensions to make the new dimensions. So the new length is going to be 12 plus the 8, which is 20 feet. And the new width is going to be the original 10 plus the 8 to be 18 feet. So this is my final answer, the new length and the new width. All right. If you would like to stop the video at this point, that is all we are going to go through. If we have time in class, we might be able to do example 6 together, but the video is long enough for me to be satisfied. So have a great rest of your day, and we'll see you tomorrow. Make sure you take a picture of your notes and submit on Google Classroom. Have a good day. Bye, guys.